Hello and welcome. Today we'll begin to learn about the subject of equations, which we also call subject of the formula. We're also going to look at how we can change the subject of the formula or subject of equations. Let's begin. Let's begin by looking at what is a formula. A formula is an equation that describes the relationship that exists between component variables that make up an equation. For example, we have an equation like y is equal to mx plus c. Familiar? Yes. So this is an equation. This equation tells us the relationship that exists between y and x. So a formula is essentially an equation, and it describes the relationship between the different variables within that formula. A formula may not be as simple as the equation that we have shown here. It may contain a conglomeration of symbols, many of which, or virtually all of which are different variables. But we will not go into that in this lesson. So for example, the area of a square. We know a square is a quadrilateral that has all its four sides of the same length. So the area of a square can be determined by a formula. For example, we can write the area of a square as A is equal to L times L, because we know that the length of each of its sides is the same, and we can represent the length of one side by L. So the area will be the product of two of the sides. So therefore the area is regarded as equal to L squared. Okay, so we see here that A is a variable and L is a variable, and these two variables are related by this equation. So therefore we know that L times L will be equal to the area. Likewise, we have several formulas for different things in maths, in physics, and all other sciences. We're going to come across a lot of formulas as we work with geometry and so on. So in maths, we use formulas to solve for the unknown variables. For example, the length of the square. If it is not known, we can use this formula to find the length of the square. Particularly if we know the area of the square, then we can find the length of the square. And how do we do that? Then we can say, for example, let's say the area of the square is 144 centimeters square. So if the area is 144 centimeters square, and we know the length is unknown, so L squared. So we know that L squared is equal to 144. So we can find L by taking the square root of both sides. So the square root of both sides will leave us with L on this side, and square root of 144 is 12 centimeters. So that is how we can use the relationship that exists between different variables in a formula to find unknown variables. We can also do this in the reverse. What if we don't know the area of a square and we know the length of its side? Let's say the length of its side is 12 centimeters, or let's use another value. Let's say the length of its side is 8 centimeters. So we know that area, which we don't know now, is equal to length times length, but we know the length to be 8 centimeters, so that's 8 centimeters multiplied by 8 centimeters, and that gives us a value of 8 times 8 is 64. That's 64 centimeter squared. So the purpose of formulas is to find unknown variables. Sometimes the formula to use to find an unknown variable is unknown, and we can derive such formulas. So let's take, for example, we have the perimeter, looking for the perimeter of a rectangle. A rectangle is a quadrilateral just like the square, but it's different in that it's got two sides that are different. So there's a long side and there's a short side, but the opposite sides are the same in the rectangle. So the shorter side, we will call it the breadth, while the longer side we call it the length. Okay, so it's got two long sides and two short sides. So we're calling the short sides breadth, B, and we're calling the long sides length. So to find the perimeter, which is just the total distance around the rectangle, we can just add up all the different distances. We know that is L plus B plus L plus B. Okay, now we can combine or bring together things that are similar. We know the L's are similar, so this is same as L plus B plus B. Okay, so two L's, when you add L to one another, what you have is 2L plus 2B. Okay, remember what we are looking for is the perimeter. So now we can also go further, because 2 is common to both of them. We can factor it out and say perimeter therefore is equal to 2 in bracket length plus breadth. So what we have succeeded in doing is to derive a formula to calculate the perimeter or the total distance around a rectangular object. So this is how we use formulas, and how formulas are made up of variables. Like in this case, the variables are the length, the breadth, and the perimeter. For example, if the length and the breadth are 2 and 4 centimeters, for example, the perimeter will be what? 4 plus 2 times 2, that is 12. But if the length and breadth are 6 and 8, for example, 6 plus 8 is 14. 14 times 2 is what? 28. So we see that they're all variable. That perimeter is dependent on the length and the breadth of the rectangle. Now, where am I going with this? This is just to tell us more about formulas and how formulas are derived. Well, this lesson will not be able to go into all the different formulas that are out there, but this is just an example of how formulas are derived and how they relate to the different variables that form the component parts of the formula. There are different forms of formula that you're going to come across in maths. For example, the circumference of a circle is given by C is equal to what? 2 pi r. That's an example of a formula. Well, when you are looking for unknown sides in a right angle triangle, we use something called the Pythagorean rule, and which says that the square root of the longest side is equal to the addition of the square of the longest side is equal to the addition of the square of one of the sides and the other side. So there are different forms of formula that you are going to come across as we work with maths. And the essential thing that they all have in common is that they are all equations. So, and that's why it's important for us to mention it at this point. They are all equations. So with all that talk, let's get back to the major crux of the matter. So what is the subject of a formula? Now in this talk, we have talked about several formulas. Let's just remind ourselves of this formula. We talked about A, area of a square is L squared. Okay. We also talked about the perimeter of a rectangle is what? 2 into L plus B. Okay. We also talked about the unknown hypotenuse of a right angle triangle is given by the square of the longest side and the addition of the square of the two other sides. Okay, so here are examples of formulas. The subject of the formula is that variable that lies individually on one side of the equation. It lies all alone by itself on one side of the equation. So if you look at these three examples that we have talked about so far, you notice that on the left hand side there are some variables that lie alone on that side. For example, in the first one, A is equal to L squared, we see that A lies all alone by itself on the left hand side. Then the second one, P, which is the perimeter, lies all alone on the left hand side of the equation. And likewise, C squared lies all alone. These ones are called the subject of the formula. So the subject of the formula is that variable that lies all alone on one side of the equation. It's possible that you might see some formulas in which the subject is written on the right hand side, but ideally most subjects are written alone on the left side of the equation. They are standalone. So can you identify? Let's look at some examples. Maybe you'll be able to identify what are the subject of the formula in these examples. So here we have about 6 examples. One is area is equal to half into base times height. Well, this is the area of a triangle. Okay, area of a triangle. So what is the subject of the formula in this? Remember, our definition of the subject of the formula is, or the subject of an equation is, that variable that lies all by itself on one side of the equation. Most times it's on the left side. So in this case, the area is the subject of the formula. So the subject of the formula here is the area. Okay. What about the second example? A is equal to pi r squared. So here we also see that the area is the subject of the formula. And the next one, we see that the radius, which is r, is the subject of the formula. Okay, next one, which is speed, is equal to distance over time. The speed is the subject of the formula. And here we have reversed the Pythagoras rule to find an unknown. One of the other sides is unknown. So here b squared is now the subject of the formula because it's the only one that is lying to the left side of the equation. Here we have written the equation of a straight line, the slope intercept form differently. You know, it ought to be y is equal to mx plus c, but what we have here is y is minus mx is equal to c. So now we have changed the subject of the formula from y. The subject of the formula now is what? C. So you should pay special attention to it. Most times it's on the left, sometimes it could also be on the right. So now we know that formulas are actually equations that tie together different variables and describe the different relationship that exists between the variables. And also we know that the subject of a formula is that variable that lies independently or stand alone on one side of the equation. Most times they lie on the left side of the equation. And that's it on Introduction to the Subject of Equations. Thank you for watching.